Good evening, everyone. We are getting started on our webinar, Heat Pumps, Everything You Need to Know. This webinar is aimed at supporting homeowners. Many of you have heard about heat pumps, but you have questions. We're going to help you know what you need to know to consider one for your own home. As the webinar is progressing, please put your further questions into the Q&A and we will answer them at the end of the presentation, and Trish might be able to write in some answers as we go as well. So my name is Michelle Yort. I'm with Neighborhood Energy Solutions, and our mission is to help homeowners confidently do clean energy retrofits easier by providing information about the technology, the process of audits, loans, and rebates, and partnering with excellent contractors to ensure fair price and highest quality installations. I'm really pleased to have with me this evening our expert speaker, Trish Long, with Switch Heat Pumps. Switch Heat Pumps distinguishes itself as an HVAC company that installs only heat pumps, no other stuff, and has a deep expertise in doing so. First, some context for why heat pumps are important. 17 to 20% of emissions come from buildings, and in cities, it's about 50%. And in many parts of Canada, our homes are mostly heated with fossil fuels. What's great is that we average homeowners can make a meaningful difference right in our own homes. We have the technology to cost effectively electrify our homes and work towards getting off gas. Heat pumps will electrify heating, hot water, and dryers. Induction stoves are a great replacement for gas stoves, and people who make the switch are amazed at how fast and precise induction is. Leak sealing and insulation will reduce your energy requirements and reduce emissions, and solar will make you an electricity producer and offset some or all of your consumption. And this is all helped by rebates and loans.
Michelle, I'm gonna pause you for a second.
Yeah.
We've had notification that people can see both our screens and various panels. So I wonder if it can go on presentation mode. Sorry to put you on the spot.
Yeah, I do have mine on presentation mode. And maybe let me swap displays. See if it makes a difference.
Thanks for the tip from Pebble. Maybe you can update us if you see a change. Oh, all good now. All good now.
Great.
Well
Thank
done.
you so much for that feedback. That's going to be much more pleasant for you. Okay. Yeah. So as I was saying, there's a lot of opportunities for electrifying your home, but the biggest opportunity by far is heat pump adoption. Heat pumps are the top solution recommended by international bodies and climate action plans because they are proven technology. They're on average 2.7% more energy efficient, and they are the most economical solution from a life cycle standpoint. What's important is that we start shifting now, because a new gas furnace installed today is locking in gas emissions for another 20 years. For this reason, anybody with gas heating should understand their heat pump options. 85% of furnaces are replaced in an emergency when they fail. You don't want to be in a position where it's minus 20, you have no heat, and you're starting fresh with your heat pump research, especially because getting the $6,500 rebate requires that you first get an energy audit. So we're now going to switch over to Trish, who's going to talk a bit about how heat pumps work in more details.
Hi, everybody. My name is Trish Long, and I'm happy to work with Neighborhood Energy Systems. And it's been a pleasure working with Michelle over the past couple of months. I started 3 years ago as an energy auditor, helping people qualify for rebates to get heat pumps and create clean tech roadmaps to get their homes off of gas. It took me 7 years to get my own home off gas. So I'm I had some learnings and made some mistakes along the way, and it was just natural to start sharing that information so people could have a smoother journey than I did. Um, and as an energy advisor, we help people with insulation and solar and a variety of things, but it was the heat pumps that was of real interest to me. With a background in climate policy, we've talked a long time about how we need to stop extracting fossil fuels from the ground, but that feels tough when we're also consuming them regularly. So most people know now that electrifying transportation can have really great results. And the next leap, it seemed to me 3 years ago, was for homes. We can do the same for homes. So Michelle has heard this many times. I'm sorry, Michelle, for the repetition, but how a heat pump works.
Well, I would just like to interrupt Trish and say that you explain it better than anybody I've ever heard because it is
Oh, thank
a
you.
bit confusing.
Thank you. Thank you. I'll do my best. We all are familiar with refrigerators and air conditioners, and those are technically heat pumps as well. If we think of an air conditioner, we have cold refrigerant coming from the outside unit where the compressor is into our house. And that cold refrigerant triggers heat exchange. It absorbs heat from our ductwork. Our warm air is coming back down to the basement. Usually it's the basement. It absorbs heat, and that leaves the air colder because the heat's been extracted and that cold air circulates in our house. And then that refrigerant that was cold has warmed up. It goes back outside and it blows off the top of an air conditioner. And everybody's felt that the air over a traditional air conditioner is warm. So when we have baseboard heating, we have 100% of efficiency. 1 unit of electricity is making 1 unit of heat. But with a heat pump, we're not actually making heat. We're moving heat from outside to in, and that can have 300% efficiency. So 1 unit of electricity makes 3 units of heat, and that's what makes a heat pump affordable. So in the winter, we've got our refrigerant loop for air conditioning. We reverse that loop, and then we have the warm refrigerant coming into our house, and our cooler air that's come back through our ductwork in our return passes over the hot refrigerant, and that makes warmer air passing through our house. Once we extract the heat from that refrigerant, it gets really cold, it goes back outside, and now our heat pump is blowing colder air than the surrounding air. So we're moving the heat. We're absorbing it from outside. We're grabbing it from outside, distributing it in the house, and sending out the cold refrigerant. And a couple of questions I often get are, well, how can it work when it's cold outside, if it's minus 20? Well, the refrigerant is minus 45 at the coldest temperatures, minus 45, even minus 50 Celsius. So as long as you have a temperature differential, it will absorb heat. And there's one other element to this whole process that helps my brain understand how it works. And that is, if you compress a gas gets hot. And if you expand a gas, it gets cold. So that compressor compresses the gas on the way in, making it even hotter. So it's absorbing heat from outside, and then you have this boost from the compression. It comes inside, that the air is run over those warm coils, making heat in our house. On the way back outside, there's an expansion valve. And everybody knows if you use a can of spray paint or hairspray, if you hold it down, that can starts to get cold. And that's because there's a gas that's expanding. So that expansion valve is what makes it super cold. So the expansion and the compression is like the booster for the heat pump. Hopefully, how did I do, Michelle? Did I miss anything on that?
I think that was great. It is a bit of a difficult concept to wrap one's head around. We do have some people on the call. I mean, you and I work in Toronto, but I welcomed people from all over. We have some people on the call from Ottawa, and actually, a woman from Alberta reached out to me and said, "Can you please make sure this is relevant to people in really cold climates?" So Trish, when somebody says to you, "Yeah, but where I live, it's colder, and I don't think heat pumps would work here," how would you explain that to them?
Yeah, that's right. There is a limit for cold climate heat pumps, and that limit is minus 30 Celsius. At that point, it won't produce, there's not enough temperature differential to make enough heat to heat your home. So what do we do if we've had warmer winters for sure, but what do we do if it's minus 32 Celsius? And I'm talking real temperature, not wind chill. With almost every heat pump that we install, we put in a backup heater. And that backup heater is the electric resistance heat. It's like having, in Toronto, we install a 5 kilowatt backup heater. It just sits inside the indoor unit, which looks like a furnace box, sits inside there. And it's like having 3.5 space heaters in there if it's 5 kilowatts. And if you think of 3.5 space heaters, how much that would heat your home, it would do a pretty good job. And then in Ottawa, where it's more realistic that you might have that weather, cold weather with more regularity than Toronto, there I would, depending on the size of the house, advise people to go with 10 kilowatts of backup heat as a minimum. So then imagine 7 space heaters and how much that would heat your house. And it's like you have 7 space heaters packed into the area just above your heat pump. And so if the heat pump's shut off at minus 30, it's not working to make heat, the air is passing over this super hot coil that's distributing heat. So there is backup heat, and we try to install it with most everyone in Toronto, but not as much as in Ottawa. And there are installers. I know an installer in Edmonton that's been using heat pumps with backups for 4 or 5 years now, and their clients are really happy. So it works.
Great.
It really works. Furnaces don't have backup, but heat pumps do. And it's not bad to use backup because overall, we are warming and we aren't experiencing those cold temperatures very often.
Yeah, I can just say I have family in Ottawa who have heat pumps and are happy with them, and they do have backup. I know you'll address this later, but depending on how tight your house is, it can make a difference too. If you're in an old leaky house, then yeah, a bit more backup. But so that's a variable.
Yeah. All right, next slide. The
Trish, I'll have you
advantages.
speak to this. Yeah.
Yeah, thanks. Advantages, and one is that it's really nice having a heat pump. We installed one 2 years ago, and my husband had been hearing me talk about heat pumps for months and months, and then finally we had one. And at the end of the first day of the heating season, it's still during COVID, he walked from his home office to my home office to say, "This is really nice." And what's nice about it is that with a furnace, it comes on and off. A furnace can only have hot air because combustion is hot. So if it's very mild out, you don't need a lot of combustion. So it comes on for just a short time, warms up the house, and then you wait for it to cool down. And then it comes back on high and runs for a short time. And it's short cycling in warm weather so that it's sized properly for the coldest weather where you need more of it. Whereas a heat pump is a bit more adaptable. It can run at slower speeds in mild weather, and it likes to run for a longer period of time. So instead of delivering hot air, it delivers warm, cozy air for a longer period of time. The other nice thing about it is that it doesn't dry out the air. with combustion, it's only hot, and that causes condensation, driving the moisture out. So many of us with forced air systems have a humidifier to put moisture back in to make it more comfortable. We took off our humidifier when we put in our heat pump and thought, well, we'll put it back if we miss it. And we've never missed it. So we don't usually install a humidifier with a heat pump, except for one client who's a cellist. She wanted a humidifier. If you've got a special need and want to control it, you certainly can, but you would use less water than you did when you had a furnace. So a very comfortable, even kind of heat. Michelle is going to speak to the lifetime cost savings, but what I've seen in 3 years is that 3 years ago, it was a little bit more to heat with a heat pump in the winter, maybe $100 to $200 over the heating season compared to heating with natural gas. But we've also seen since then the price of natural gas go up. And the 2 winters ago was a break even. And last winter, my clients that thankfully tracked this information for me reported that they had spent less on heating. It's a little tricky because we have to adjust. It was a very warm winter last year. With adjusting as best we can for weather, it's been a little bit less. So I've not had anybody upset ever with hundreds of installations, maybe 500 people I've been in contact with that have installed heat pumps. Nobody has circled back to say, I can't believe how much this costs. So if you think of it as comparable to gas and slight savings, it's that's very realistic. And of course, we're doing this to reduce emissions. And if only 1% of us do it, it doesn't make much difference. But it seems like this heat pump business is catching on. And 3 years ago, the conversation was, "What's a heat pump? I've never heard of a heat pump." And these days, it starts in a totally different place. It's, which heat pump is right for my home? Or should I have a ductless heat pump or a central heat pump, or can it heat water? And so it's really remarkable to see that change. We're definitely going the right direction. Next slide.
Great. Well, I'm just going to do a high-level overview of the types of heat pumps. We are going to be focusing on air source heat pumps here, but just to clarify and to avoid confusion, I'm going to speak quickly to the other types of heat pumps, which include ground source heat pumps, sometimes known as geothermal, air-to-water heat pumps, heat pump water heaters, and heat pump dryers. So ground source heat pump, you can see here, this is also extracting heat from the ground or putting heat back into the ground, depending on whether it's summer or winter. The vertical loops are installed usually in urban areas where there's a shortage of space. The horizontal loops are done in more vertical areas or sometimes in new construction where they can get in ahead of it. It costs less, obviously, than drilling. Because of the consistent temperature of the earth, the ground source heat pumps have up to 500% efficiency. They do have a higher upfront cost, but they have excellent efficiency, excellent long-term life cycle value, and are a strong option, especially for new construction or in rural areas. We're not talking about them a lot in Toronto. The air-to-water heat pumps, so these transfer heat from the air into a hydronic or water-based system. It's a great fit for in-floor radiant heating. Those of us in our older homes with our beloved cast iron rads, the air-to-water could work with your existing radiators for heating mode. Not definitely, you have to get a good talk to somebody who knows what they're doing, but you're not going to get cooling like you would with air source heat pumps because the cold water running through the pipes would cause condensation and mold behind your walls. To get air to water with AC when you have rads, often people will use the mini splits or the multi splits that Trish is going to be talking about in it for cooling and for some heating. So heat pump water heaters are looks not that different from the outside as our typical water heaters, but you can see they've got the heat pump guts with evaporators, compressors, condenser coils, and they are 2 to 4 times more efficient than a standard electrical water heater. They draw their heat from the surrounding room, so they do require some space around them. Like with other heat pumps, they have a higher upfront cost, but given their really high efficiency, the payback is about 5 years and even shorter if you're with a lot of use. What's also interesting is for those who are trying to keep their electrical consumption low to avoid a circuit panel upgrade, the heat pump water heater with its high efficiency could help you with that. And the upfront cost of the heat pump water heater will be much less than the cost of a circuit panel upgrade. And Tricia is going to speak more about circuit panels in a little bit. And there's also heat pump dryers. This is the one that I have in my house. These are like the heat pump water heaters there. They don't have an outdoor unit. All of the different parts are on the inside of it. As you can see, they have fantastic energy efficiency. They have in this area right here, they actually have a little container that the water goes in because it condenses the water out. These don't vent to outside. So you don't have all of that hot air being wasted to outside. It actually reuses the hot air, and that's part of why it's super efficient. You do need to empty that little water container, or you can install it so it will empty into the same as your outgoing washing machine water. And now I'm going to switch back to Trish to discuss the types of air source heat pumps.
Thanks, Michelle. And it's
You're
perfect because
welcome.
I just had some fun answering some questions. And
Good. And Trish, too, like you know way more than I do about any of this. So if you want to jump in and add additional comments to anything I'm saying, please do.
and you did a great job. Perfect. So I had a couple of questions, and most of them were asking about, can I use my furnace with a heat pump? And that's perfect. So I'm just going to jump over to the picture on the right of this slide where Michelle's written hybrid. And there's also a picture of the coil there. And what that is that that's an existing furnace. And normally there's ductwork above, metal ductwork above a furnace. Many of us have an air conditioner coil in that ductwork. We may or may not know it. What that looks like is an A-frame with refrigerant lines that loop. Michelle's done a great insert down there for me where it says coil. That's to show, how the air passes over and the heat exchange happens. So if we've got an air conditioner one in there and we want to switch to a heat pump, we remove the air conditioner outdoor unit, we take out the air conditioner coil. It's often, and then we, to get the rebate, we have to put one that comes in a case or a box. And it's got a sticker on it with a model number that Enercan has on their approved rebate list. And our clients are getting a $6,500 rebate on this heat pump. And in this particular case, the furnace was broken, so the homeowner didn't need to keep the gas as backup. This is a well-insulated home, and we did a careful calculation to find that this 3-ton heat pump would fully heat their home in a Toronto winter. So they've opted to go no backup, which is an exception for our installs. If we found, this was another question about how backup heating works. If we found that at -25, their heat pump couldn't fully heat the home, I would estimate, say, maybe if their set point is 21 Celsius, that might mean maybe their house can only get to 18 or 19 Celsius. And they don't want that interruption in their 21-degree set point. We can retrofit a duct heater into their duct work. It's a little bit of work. It's a couple $100 for the part, and half a day's full day's labor in connecting it all. So maybe that's an $800 add-on. to add backup heat in this scenario. But this family is willing to try it on its own, just because they've done those upgrades to make the home super efficient. It's not that likely they'll need it. So that's the hybrid one. If they had kept the gas, then people often ask when it will switch over. It's funny, we install these with EcoBees, and the EcoBee default temperature to flip over is it's either 1 Celsius or -1 Celsius, I forget, but it's right around zero. And that's sort of an old-fashioned flip over point from when heat pumps were designed to only work to 0 or -5. Many of the heat pumps we've had in Ontario for decades, heat pumps themselves are not new, but we've had them for decades. They just weren't cold climate heat pumps. These heat pumps only work to 0 or -5. And usually that was fine because these were made in Texas or Georgia, and they weren't that interested in cold winter heating. It wasn't necessary. It was actually Japan that did a lot of the innovation around the cold climate heat pump. And the difference between those older heat pumps and what we call cold climate heat pumps is that the speed of the refrigerant flow can vary. Originally, probably the first air conditioner and heat pump only had one speed that the compressor ran to run the refrigerant loop. Then they got a little fancier and there was a second speed. Now these heat pumps can run at a whole range of speed, including really fast. So it uses more electricity when it's running really fast, but even at the coldest temperatures, it will still be as high as 200% efficiency. So half the cost of using a baseboard heater. So yeah.
Trish, I was thinking one thing with the hybrid is that there are people who may have a furnace that's relatively new and is working just fine, and it sure doesn't make sense to throw it in the garbage. However, maybe their air conditioner died, or maybe they don't have AC, but they're interested in having the add-on heat pump, using their furnace, continuing to use it. So, and that's also, if I understand correctly, a hybrid system.
Correct. Yeah. Yeah. So you can do a hybrid with the backup as gas. Oh, and thank you for bringing me back to that. What is the temperature you want to set to flip it over at if you've got gas as backup? And that depends on the heat load of your home. For our clients, we'll set it at -15 Celsius or -20 Celsius, and then they can adjust it when they find the real heat load of their home. But most of us want to minimize the gas use completely. So yes, and I know that we have people that are installing the heat pump now, and they're very comfortable keeping the gas as backup. And I would be really surprised in if a couple of years they find they really trust that heat pump, keeps them warm even in the coldest weather, and then they'll be comfortable disconnecting the gas. But yes, right now it's a great deal. And price ranges, those heat pumps range from $6,500 to $8,500, and there's a $6,500 rebate on it. So we are installing bunches of those right now. The other one that we install a lot of is on the left side. It's called central ducted. And as you can see, it looks a lot, it's boxy like a furnace. And you've learned what the coil is for where the air exchange happens, the cold refrigerant lines on your coil. I can tell from this picture, I see the refrigerant lines, which are made of copper. They're wrapped in black insulation. I see the refrigerant lines coming down and going into the front of that unit. So I know that that heat exchange coil is sitting at the bottom, which means that on top of it is the blower motor, which circulates the air through the house. And then at the very top, it's hard to see, but above, it's a Move Air, above the Move Air orange sticker. Michelle's marking it for me. Thank you. That's where the backup heater has been inserted. And it's a separate item, but we include it with our installs. And it's, like I said, it's just a regular electric heating coil, like having, this one is a 5 kilowatt. So it's like having 3.5 backup space heaters in there that would come on if it's quite cold and either the heat pump doesn't make the load or it's -30 and it's relying on that entirely. So that's a full system. In the middle, we have at the middle bottom, we have the outdoor unit. I had a good question about how do they compare noise-wise to air conditioners. The traditional air conditioners that are round and blow up tend to be quite noisy. And these heat pumps have a different shaped blade, and they're also not made of metal anymore. The upright air conditioners are metal, sort of blunt shaped blade, and the outdoor unit pictured here has 3 blue resin, somewhat tapered blades. And it's the shape of that blade that makes it much, much quieter. So compared to an air conditioner, it's just lovely to listen to a heat pump. And at the top, we've got a picture of a mini split or ductless, or we call it a multi-split if it's one outdoor unit with multiple heads. I had a good question about that. Can you pair that if you've got a boiler system with hydronic heating in your house? We have people putting these in sometimes as a supplement. It does air conditioning and it can also provide heating. But it doesn't quite do the same job as radiators. Radiators, you usually have them in every room, including the bathroom. You can't put one of these heads in little rooms like bathrooms. They don't fit. So the heat doesn't distribute quite as well with these as they do with radiators. But if it's a long-term plan, sometimes people add bathroom floor heating or far infrared heating panel to areas where the ductless units don't split. And just to wrap up on costs, as I said, the hybrids range from $6,500 to $8,500. The central ducted units range from $13,000. This is and I've seen prices as high as $24,000, $25,000, and that depends on brand, which we can touch on shortly.
And then there's also the combo where people might have a ducted unit in floors 1 and 2, and then they might have a mini split head up on the 3rd floor, for instance.
Very good point. Very good point. That's sort of a new thing on the market in the last 3 years. I haven't seen very many of them yet, but you can have a central unit. But if there's sometimes there's a 3rd floor that doesn't even have ductwork. With the same unit, you can run refrigerant lines separately up to your 3rd floor and have one of those mini split ductless units on the wall up there. Yeah, great.
Yeah.
Next slide. Heat pump brands. There's at first it was just Mitsubishi. Everybody was installing Mitsubishi, and they're beautiful. I describe them as I should have a better comparison. I use a car comparison, a Lexus versus a Toyota. If you've got an eye for heat pumps, they just are slightly higher quality, and I would say whisper quiet if you wanted the quietest possible outdoor unit. Daikin, also Japanese brand, Mitsubishi, Fujitsu, Daikin, all Japanese brands. The Daikin is also incredibly quiet. So those are very nice, but their prices are high. And those are the ones that I see in the $20,000 to $24,000 range. And it really does cost an installer, $6,000 or $7,000 more to buy that unit, to put that unit in your home. So we install them, but not as much as we're installing the other ones. The other challenge with Mitsubishi is we're doing installations in Toronto and our basements aren't very tall. The Mitsubishi has a very tall indoor unit. So in early days, I knew an installer that didn't measure very well, and they ended up having to rent a jackhammer to drill down into the homeowner's basement to make room for that super tall air handler. These other brands, they're either Chinese brands, they're all Chinese made heat pumps, but some of them have North American brand names put on them. The two big Chinese companies are Gree and Midea. We have those two logos there. You can't buy either of those. You can't buy a Midea in Canada under that brand name yet. So it comes under the label Move Air, Mitzair. I think there's one called Eco Home as well. And I've Trust Air Conditioning, and I've seen these heat pumps made by Midea, and they all look exactly the same, just with a different sticker and a different model number on them. And the brand name Move Air, for example, that's done by the distributor in Canada that's selling that Midea heat pump. And that distributor is providing the support to the installer should something come up. We need a fan blade replaced at one home. We go to the distributor, they get it for us. We don't deal with Midea directly in Canada. And then and some of the others, the Train, the Carrier. I shouldn't be. I know the Train is Agree.
I think
And
Carrier's Medea.
is Carrier Midea.
Yeah.
And I've seen Napoleon, which I believe is Agree because it looks like Agree. Lennox and York. I'm not sure. Do you know, Michelle?
No, you know what? I just put a bunch of the names here to kind of make the point that most of them are made by either Gree or Medea. So people get, of course, they want to understand like what's the difference between these brands and think, well, you know what? A lot of them are
Yeah.
actually the same thing.
Yeah.
Yeah.
Yeah. There's some white labeling of appliances. I did see a heat pump the other day, and it was one of the traditional round air conditioner ones. Um, Gosh, I think it might have been a Carrier. And I'm not an expert on them. We've never installed them. They look strange to me, having worked with the side profile ones, because the side profile ones are quieter, and we put them up on a snow stand. So it seems strange to me to have a heat pump on the ground. I know you can put a round one up on a stand. It would be handy if you've got a location where the side venting doesn't work. If there's only one spot on a row house to put a heat pump, maybe you need something. But I did notice it was louder than the heat pumps that are side venting. And I just thought, if you're buying a heat pump, why would you go with louder when you could do quiet? But that's a personal bias. And more important than brand, the experience of the installer. Yes, the technology for heat pumps is the same as it was when the first air conditioners came out, in that it's a refrigerant loop, and you need the installer to put that together with care so that it never leaks. And occasionally, I saw one last week, a 50-year-old air conditioner that's still going. And that installer did a terrific job. They put it in a secure location, and the refrigerant loop hasn't failed. We test our refrigerant lines 3 times. So make sure that enough time is spent on your installation. You can attach a heat pump to existing refrigerant lines, and especially if they're not very old, you would want to reuse that copper. But if the refrigerant lines are really old, there's a good reason to replace them with new ones, because the install you get, you want that install to last for 30 years. And the copper is 100% recycled. Copper is very valuable. It does not go to waste. So make sure the installer doesn't cut any corners on the installation. It should be like I said, a 30-year job.
One of the things I'll just say quickly, Trish, around experience of installer is just that a lot of HVAC companies who have a long history of working with gas, and they're really experienced with that, they're just getting into heat pumps. And if they, from what I understand, if they apply the same principles that they would when, say, for instance, sizing a gas furnace, they're going to do the wrong size heat pumps. And I've talked to people who've had a 4-ton heat pump put into to their home, and it failed quickly because, you know, the blower was much too big for their ducts and this sort of thing. So there is that piece that I would say that you want to make sure that your installer has done a lot of heat pumps, and that it's more important than the brand of the heat pump is the experience of the installer.
Yeah. Yeah. And that leads me to want to build on tip to that is that I'm seeing people with furnaces, the companies are selling the heat pump over the phone. They don't even come to the house, and they'll just put in a 2-ton, but they aren't thinking about whether in a couple of years you want to get off gas completely, if that's the right size for fully heating your home. The heat pumps that we install when we do it with a furnace, we're thinking, okay, we've seen this. So people change their minds about gas and it can happen quickly. If in 3 years' time you want to disconnect from gas, let's have that heat pump be the right size and the right unit. You know, our units that we install with the hybrid are the same as the one we do for the full system. So if you wanted to buy that indoor air handler later to get the furnace out, or if the furnace broke down, it's compatible.
Right. And another thing that I've heard about in terms of the different brands is that you could have done some research and found a brand that you think sounds great, but if there's not the reliable local distributor for parts and support, that's going to be a problem.
Yeah. Okay. And Michelle, you're so efficient with the slides, and I'm a little bit slower. So I'm going to turn it back to you to crank us through the end here, because we've reached our time.
Okay. Okay. All right. Well, let's see. And you talked a little bit about this, Trish, we did cover getting a good installation.
Let me just jump in on that slide and say the size of the ductwork. We always measure the size of the ductwork. If your ductwork can only handle a 3-ton heat pump, there's 0 point in the airflow from a 3-ton heat pump. There's 0 point in buying a 4-ton heat pump, or the same if it's a 2-ton maximum. Don't buy a 3-ton. We don't have to think about this as much with a furnace because the air is hotter. You don't need as much volume, but because a heat pump is warm, cozy air, we need a slightly larger volume of ductwork. Now, you don't need, if you're doing new construction, I don't recommend people oversize ductwork. I think you're better to do a smaller heat pump with backup heat, because we've retrofit hundreds of homes using existing ductwork, and it's worked just fine. If you do bigger ductwork, you have bigger bulkheads and lower ceiling heights, and all sorts of problems arise from that. I've seen that too. But yes, you make sure your installer is knowledgeable about ductwork.
Mm-hmm. And I did flip to the ductwork slide, and you might want to speak to the AeroSeal piece.
Mm-hmm. So something we found when we put in these right-sized heat pumps is that the blower wasn't as big as the old furnace in homes. Sometimes the furnaces in homes had been sized up by the installer to try to push air conditioning up because people said they didn't have enough air conditioning upstairs, and the only solution was to have a bigger blower, which meant a bigger furnace. Now there's this technology called AeroSeal, where they come into your home, they cover all of your air supplies, they pressurize the system. You can see the picture in the bottom there with the compressor. And there's an aerosol, the aerosol has a sticky acrylic compound, a glue, water-soluble glue in there. It's non-toxic, little tiny bits, so it sort of looks like a snow globe when you shake it. That gets pressurized in the ductwork, and it goes to all the gaps and cracks and fills them. It can fill a hole the size of a toonie. It's really quite amazing. I have hundreds of clients that have raved about it, said it's life-changing, transformative. Their bedroom's never been comfortable before. And the best part is that it gets 30 to 40% more air conditioning upstairs. So sometimes HVAC companies will tell you, oh, you'll never get air conditioning upstairs. You've got to buy this separate ductless unit. I 100% recommend checking out AeroSeal first to see if it's right for your home. It's $2,500. You don't even have to be doing anything else to your house to make it comfortable.
Awesome. And I do want you to speak to the panel upgrade question.
Yeah, so in Toronto, like I said, we have the luxury of having smaller backup heaters. So if you're in Ottawa or Alberta, maybe you do need 200 amps because a 10 kilowatt backup heater will be a 60 amp breaker, and on a 100 amp panel, that's a lot. In Toronto, we put in these 5 kilowatt backup heaters that can go on a double pole 30 amp breaker. And that's a lot more reasonable on a 100 amp panel. So I have bunches of clients that have electric hot water heaters, just the regular kind, a heat pump, and an induction stove, and some even have car charging, electric car charging, and they're still on a 100 amp service. And we haven't had anybody with a panel that's tripped. But it does depend on what else you're doing in the house, how many people, and if you have something else that's a big load, if you have an apartment in the house, if you have 2 dryers, if you have a hot tub, a swimming pool, or 3 kids that spend too much time in front of computers and big TVs like my kids, then maybe 200 amps is right for you. For car charging, a little tip, most of the time, even if you've got a fast charger, you don't charge it at the highest rate because it's more efficient to do it at a lower rate. So even if you can charge it at 40 amps, you might actually charge your electric car at 20 amps. There are some smart panels coming where you'll be able to manage the load, and your smart panel will be programmed so that, well, if the car is charging and a bunch of people are doing other stuff and it's minus 30 and the backup heaters come on, maybe the car charges for 15 minutes while the backup heater's on, or pauses while the dryer's on, because usually cars have time to charge all night, so it's not a big deal if they pause for a while. So smart panels can do that. There are also switches or load sharing devices that let you do that. And in terms of costs of panels, it's not cheap. A new 100 amp panel, if you've got a super old one, is about 2,500. 100 amp smart panel, these are installed prices, is about 3,500. And then for a 200 amp upgrade, it's about 3,800 plus Toronto Hydro charges $700. So you're at 4,500 to upgrade to a 200 amp service. I hope it's less in other parts of Canada, but that's what we're seeing in Toronto these days.
Okay. Let's do a quick overview of the incentives.
Yep. So across Canada, everybody's eligible for the $5,000 federal heat pump rebate as long as it's a primary residence, your primary residence. In Ontario, that jumps up to $6,500 because Enbridge is reluctantly throwing in $1,500 to boost that up. In BC, it's $9,000 or more for a heat pump. It's just it's all systems go in BC. But you must have an energy audit done before you have the heat pump installed. An energy audit, an auditor comes, you pay about $600 for a pre-retrofit audit. They give you a report, a bit of advice. You install the heat pump, maybe a heat pump hot water heater, which qualifies for a $1,300 rebate. And then you get a post-retrofit audit, which is $200 to $300, and you get $600 back towards the cost of the audit, plus the $6,500 for the heat pump. Yes, and there's a Canada Greener Homes loan, which is up to $40,000 interest-free. Why would you pay up front when you could pay over 10 years, especially when we have high inflation? The website to sign up if you're in BC, Ontario, or Nova Scotia is cghli.ca. Please use that one and not the Natural Resources Canada website. If you are not in those provinces, then you use the Natural Resources Canada website to apply for that.
Okay. And I'll just do a very quick review of a couple of slides that are talking about the 15-year lifetime costs. And this is because people want to know, like, wow, these heat pumps are expensive. And you see here in the green area, it's showing you the upfront cost and this is air source heat pump and heat pump water heater versus buying the conventional. But over 15 years, you see considerable less heating and cooling cost than you would if you were on the gas appliances. And if you're actually cut your gas line, then you're going to save another approximately $4,500 in savings over those 15 years. And then this is just comparing. There's certainly an advantage over gas, but if you're somebody with heating oil, propane, or electric resistance, the savings are even more. There is a pretty cool calculator that the Ontario Clean Air Alliance has on their website, so go check it out. You have to put in your consumption of gas over a year, and then it'll let you know what it would save for you to switch. And with that, we're going to switch to Q&A. Now we are it's 7:51, and if there's continued interest, Trish and I will stay on, but please feel free to drop off the call if you want to. We are recording this webinar, and we'll make it available to you folks who are participating. All right, Trish, are you seeing the questions?
I see some hands up, and I see some questions in the Q&A. So why don't I start with those?
Okay.
And Becky has asked, how much does it take up the footprint? How much space does it take up the footprint? And I assume that means the outdoor unit is about 3 feet wide and 13 inches deep. They're 18 inches off the ground and then about 2.5 feet tall. So about 5 feet tall. Oh, geez, my math on the spot. 2.5, 4 feet. 4 feet tall makes more sense. And then the indoor unit usually takes the same space as a furnace does. Although there are a few more options for space. If you've got a really small basin, like we see in Toronto, you can do an air handler that hangs from the ceiling, and then your ductwork never comes down to the ground and goes back up. It's just straight on the ceiling, and your ducts go in and out. Can I explain more about what a duct heater is? Essentially, it's just electric resistance heating, just like a space heater. If you wanted to look them up, there's a company called Thermolec that makes duct heaters. And I've seen them, sometimes they come in a case that's sort of a standard size. So standard size ductwork is about 8 inches tall and say 12 inches across. There's probably a Thermolec heater that comes in a box. So you just kind of sever your ducts at both ends and put this duct heater in between. And then as the air is passing through, it's heated. So it comes in your ducts after the heat pump. So the heat pump is heating it as much as it can. And then the duct heater gives it the boost as it goes through. It's easiest to do when it's built into a heat pump with a full system, but not impossible to do it otherwise. I have RADs and radiant heating in basement. Can heat pump work for both? And no AC for me. Yes, so air to water heat pumps, you can have a heat pump. In the simplest way to think about it It's just a regular heat pump. It's grabbing heat from outside. You bring it in the house, and then you heat a tank of water. And then that tank of water is on a pump. And when your house needs heat, the thermostat calls for that hot water to go to your radiators. So, yes, it can be done. Unfortunately, there are no rebates for it. So it might cost you $12,000. It might cost you $24,000, depending on which system you go with and who you can find to install it. And no rebates. And it doesn't usually do air conditioning because of condensation. If you put cold water to cool into your radiators, all those copper pipes behind the walls would drip when they hit warm air, and you'd get mold in your house and be very disappointed. But if you were renovating a house from scratch and you insulated all those water lines, you could put in a modern radiator, which we can call a fan coil, and it's connected to electricity, has a fan in it, and the hot water can come in and you have heat. The cold water can come in and you can have air conditioning. So you can have a hydronic system that's done both, but the system in your house has to have been built for it from the get-go. So what I have people doing, so most homes in Toronto, as it's getting hotter and people need air conditioning, are pairing their radiator system with mini split heat pumps. And the rebate right now requires that you have a mini split head on each floor of the house. So people are often doing 3 on the second floor, 2 on the main floor, 1 in the basement to qualify for the $6,500 rebate, or $5,000 depending on where you live. And they can use that for the spring and the fall, and they'll use it in the winter until such time as it becomes uncomfortable in the house. Usually boilers in our house go into the bathrooms and the front hall, where you may not have a mini split. So it can get a little bit uneven in the colder weather. And so people may still want to turn on their boiler at a certain set point, but it can mitigate how much gas you use.
Trish, about how much room does a heat pump water heater require around it?
Yes, about 10 by 10 is the room, the rule. But you could get around that if it's in a closet, if you put a grate on the door or a louvered door, if there's some air exchange with the outside room. So the way heat pump hot water heaters work is they're taking the integrated type, where it's a tank and the heat pump sits on top. It takes heat from the room, that heats the water, and it vents cool air. So if you had it in a closet, that venting of the cool air, that you'd get a microclimate and it would get very cold and less efficient. But if that door is louvered, it can exchange air with the surrounding space. So some people ask, well, what's the point of, if it's going to cool your house, you're trying to heat your house? Well, this is just a very small amount of heating to heat a tank of water compared to the large amount of heat we need to heat our homes. So most of the time, your heat pump hot water heater isn't running. So I have one in my home and it's not a big deal. It's in our laundry mechanical room. If it's running, it's a degree or two cooler in there, but most of the time we go in there, it isn't running. But you might not want to put it right beside a desk where somebody's working, because we're not used to water heaters making noise. In that case, if it's in a closet or in a guest bedroom, then we often do a regular electric tank with an off-peak timer. So you heat the water at night when electricity is cheap, and then you use that water down during the day, and then it reheats at night. You use it down the next day. And
Trish,
prices for that, about $4,400 installed for a heat pump hot water heater, and 22 to 2400 installed for a tank with timer.
Question, if you start with the gas as backup and you want to disconnect the gas service, can you simply remove the gas furnace with a professional's help and use only the heat pump for heating?
You would need something to circulate the air in the house. So the furnace, the box we call the furnace, is also an air handler. Air handler means it's handling the air in our house by blowing it around. So you wouldn't take out the furnace in that case, but this is what I have in my home is I have a furnace where the gas line has been disconnected and the flue vents have been removed, but the blower is still working in my house to blow the heat from my heat pump around.
Yep. So the answer is yes, you can remove. Like you're leaving the blower from the gas furnace to be used with the heat pump, but you can cut the gas line.
You can cut the gas line and no longer use the gas component of the furnace.
Okay. A question, can you use the heat from the condenser in the summer to heat your pool?
Yes. If they're located in reasonable proximity. So you need your pool plumbing near your air conditioner or near your heat pump outdoor unit. So yeah, you can Google that and see people that have done that. The one catch is that that's going to work best in hot weather when you've got your air conditioning on, but it won't help you much in the spring or fall when the pool's cold and you want to warm it up for an early season swim because you may not have the air conditioning on very much in your house. It will only heat as much as the air conditioning is on.
All right, here's a chance for a wee commercial. Somebody says, "Hi, what is your company called? And do you install heat pumps?" I joined late.
Contact Michelle. Neighborhood Energy Systems is great, and they do full service clean tech roadmaps and can guide you through everything from um, audit to solar to electric cars to heat pumps, and we're happy to partner with them and do installations with them. So yes, Neighborhood Energy Systems.
Thank you, Trish. Yes, neighborhood energy solutions. And so the idea
Sorry.
for us is that because this whole process can be kind of overwhelming, that we help increase the confidence for homeowners to understand the technology, to give you a good referral to somebody like Trish, and to help you understand the whole process so that you can feel like you're going to be getting good service, good cost, good installation, good value. Let's see. Some of these you answered. You did, I was busy typing, but there's a couple of questions about homes for RADs with cast iron radiators, and you did address that, right?
Mm-hmm. I
Um,
think so.
yeah. Do you also install ERVs? I'm not sure whether you guys have done any of those,
We
Trish.
do we do ERVs. Yeah.
Okay, great.
Yeah. So an ERV, for people who don't know, energy or enthalpy recovery ventilator. As you make your home more airtight, or if you're building a new home, renovating a home, and you're using wrap, it's going to become more airtight. Um, and we all exhale carbon dioxide, and in an older leaky home, we have natural ventilation, but in an airtight home, that could build up, making it stale. And so what an ERV does is it's often paired with your duct system, and it sends stale warm air out and then brings fresh cold air in. We need this more in the winter because our homes are sealed up more. We don't have windows and doors open as much. And the cost to have an ERV installed is about $4,000 to $5,000.
Trish, somebody asked, I've seen heat pump outdoor unit models that look like the traditional outside AC units. shape
Mhm.
wise. Are they also quieter?
No, I saw the first one about 2 days ago, and I I was surprised that it was noisy. It sounded like a regular air conditioner.
Hmm.
Um, and Michelle, I'm going to let you cover for a sec. This is embarrassing, but my battery lights come on. I'm just going to plug in.
Okay, go for it. Um, let's see. I'm just looking for somebody asked, are Bosch heat pumps a good brand? It's not shown in your list. What would be its price range? So the list that I made was not a comprehensive list of every heat pump brand. It was really more to kind of illustrate how many there are and how overwhelming it can be. And that really it's more important that you get an installer who, one, is experienced with that brand, but also that they have a distributor who would be able to provide the parts for the brand and be able to offer support to their installers. I think I have read that people have liked their Bosch heat pumps, but I'm certainly not an expert on it. And it's interesting too. You'll see regional trends, and I think it's because that there's a good local distributor there. So it might be that your friend and your friends in BC are like, "Yeah, Bosch, we love it," but that might not be the right choice for you in Ontario because maybe that distribution network isn't there where you are. So do you know if you get an installer that you feel confident, you've checked their references, they've got a lot of experience, and they probably install two or three types because they have a good relationship with their distributor. You might just want to go with the types that they install.
Yeah.
They'll probably offer you a couple of options. But Trish, I'm sure you could add to that.
Yeah. If you talk to enough installers, every brand is bad because everybody's had some bad experience with some brand, and somebody's sworn off it. The ones exactly as you said, if the installer's comfortable with the brand, they usually install a lot of them, and that means they get good support. Exactly that. So yeah, as you say, check references. Asked to speak to a couple of clients that have had heat pumps installed.
Mhm. Here's a question. Just I think there's to
Oh,
clarify.
and maybe one thing we haven't emphasized so much is what temperature does the heat pump operate down to? Um, there are heat pumps that operate down only to minus 15 Celsius. I don't know why you would install one of those in Ontario or Alberta or um, other places in Canada. Most maybe you don't need it in Victoria, but if there are heat pumps that operate down to minus 30, why wouldn't you just choose one of those?
Yeah, completely agree. And somebody says, do I understand right that you need a central ducted unit if you don't already have an existing backup? And if you do have an existing backup, you would get a hybrid.
That's a tricky question.
Mm-hmm.
uh,
Mm-hmm.
one of those, could I have those one at a time?
Yeah. So, and so it's do I understand right that you need a central ducted unit if you don't already have an existing backup? And I'm not sure exactly what they
No.
mean, but I'm guessing if it could be if your furnace is end of life, you're going to get rid of it and start new with a brand new central heat pump. If you have a furnace that's only 5 years old, 6, 7 years old, it might make sense for you to use that, especially that you can use the blower and the motor on it and add the heat pump coils on top, use the blower motor from the hybrid, get all of the benefits of a heat pump. And you could use that as a backup, or you could cut the gas on it.
Yeah. So you can do backup with with different configurations. There's always a way to do backup, and backup can take different forms. I have a client who was renovating and they put underfloor electric heat on their entire main floor. and that's their backup heating. So they don't need it built into their ductwork. If they need a boost, they'll just warm up the floor. Um, some people don't have access to the electrical panel. If your electrical panel is at the other corner of the house from your mechanical room and your basement ceiling's finished, running a wire for the backup may be too complicated. Maybe then you'll buy 3.5 space heaters and put them in a closet for when it gets really cold. And you'll do spot heating. It doesn't have to be something built in, but that's what we do most often. And if you have ductless, if you've gone with mini splits, and I have clients that are renovating and they're not putting in ductwork, they're putting ductless units so that they have remotes and zone control. You know, you can have the upstairs at any temperature and the downstairs at any temperature you want. It's kind of nice. They don't have backup with their heat pumps built in at all. So they can, but maybe they're putting heated floors in the bathroom or front hall, where a heat pump doesn't fit or doesn't reach, and they've got backup in that form.
Here's an
I have
interesting one.
a client with a wood burning fireplace as backup, a wood stove as backup.
True. Can you sell a used air conditioner unit?
Not for very much. Couple $100. Post it while it's still connected to your house, because if it's disconnected, anybody that's going to buy it doesn't have any assurance that it works. And to pick it up, deliver it, install it, and then find out it doesn't work, nobody's going to want to take that chance. So post it ahead of time. I posted my gas stove, and because of COVID delays for product, I ended up waiting 8 months for an induction stove. But I'd posted it earlier just to check and see if somebody would take it. And somebody waited 8 months and they were still happy to come get it.
Great. How do you know if your heat pump was installed properly?
Hmm.
That's a tricky one.
That's what have I seen? I've seen many things go wrong. Um, uh, it should um, your heat pump, if it's paired with a furnace, should be set up as stage 1 heat, so the heat pump comes on most of the time. The furnace should rarely come on. I have seen installations where it's been programmed to just flip over at 0 when the heat pump's capable of -12 or -15. So I think there is that tendency, if installers have to guess, they're going to guess a higher temperature so they don't call you about changing that threshold. But for example, on an Ecobee, you go to settings, installation settings, thresholds, and you can set the threshold for where you automatically want the furnace to come on. I have seen a situation where somebody's heat pump was just running all the time. And in that case, it turned out to have been a refrigerant leak. If they had heard that heat pumps weren't hot, so it was producing something that was warmer than the room, but not warm and cozy. So that's why I say warm and cozy. If it's not producing warm and cozy air, then there might be something wrong.
How do you test the existing ductwork to see how much airflow it can handle?
You can measure it. So a standard ductwork, usually a small house will have one trunk that's usually 8 by 20. And that might support, say, 1,000 CFM, cubic feet per minute, which translates about to a 2.5-ton heat pump, because a rule of thumb we use is 400 CFM per ton of heat pump. If your house is bigger, you might have 2 of those, 2 8 by 20s, or an 8 by 20 and an 8 by 12, and then you would be closer to having capacity for a 3-ton heat pump. So I use something called the Natural Resources Canada Heat Pump Sizing Guide, which is a very long, a multi-tabbed document with lots of text, but there's one tab for design loads, and there's a duct calculator in there that I like to use. So yeah, measuring the size gives the approximation. You may or may not have good airflow through that ductwork, but that's something that a good installer can check on.
Mhm. Will the grant still be available if the federal or provincial governments change?
Mm. Conservatives love to cancel green rebates. Um, but we haven't had an election called yet. So yes, that could happen. There has been some talk about there not being enough money, but what the statement actually was from Natural Resources Canada is that they can't guarantee grants for people that haven't had a pre-retrofit audit before March. And that coincides with our new budget, the federal budget for 2024. We'll get an announcement of whether there's more funding for it at that time. So I think if you're thinking about a heat pump in the next 12 months, I'd certainly be getting my audit sooner rather than later. Because even if the Conservatives come in, they know that we're all voters. And if we've already paid for an audit, they're not going to want to cut us off and say, you can't have anything. They're going to want to let us get through the program, but they're going to shut it down to new entrants.
And that is a nice segue. Somebody says, where do you suggest we go to get an energy audit?
Contact Michelle.
I can refer you to some good people. Yes, there is an official list. You do have to use a certified energy auditor, and I think on the NRCan website, and or depending on where you live, the Enbridge website, they do show lists of them. And but if you're interested
Yeah,
in one
they list service organizations, um, and not individual advisors.
oh, okay, okay,
Um,
okay. Someone says, why would you use a duct heater instead of installed in the heat pump?
if you're putting in a full system, you would install it in the full system directly. But right now, everybody's putting in a hybrid with their furnace, but some of those people want to get off gas. That's when we need to do something custom in the ductwork.
If you buy a central unit, there is a little place that you can put in the backup heat.
Yes.
But in the hybrid case coil add-on systems, plunk that you put on top, they do not have that little space.
Correct.
Okay. Okay. I have a knob and tube wiring and 60 amps in my home. It has a central gas furnace. Would it be safe for me to add a heat pump to create a hybrid system?
Mm. No, you should upgrade your electrical. Um, if you have an air conditioner, I don't think a heat pump would be very different, especially if it were the same size. But no, for a home that's electrifying, 60 amps is not enough, and knob and tube wiring isn't recommended. The heat pump, again, it's the same as an air conditioner. A heat pump doesn't use that much electricity because it's trying to run this refrigerant loop nice and slowly. It's that backup heater that is a 10 kilowatt backup heater that's the really big load. But I've only seen one 60 amp panel in Toronto, and it was upgraded.
But to be fair, if you do hybrid system, you wouldn't need the 30 amps for backup. Is that correct?
Correct, but you need a 30 amp for the heat pump. You need
Ah,
one
right,
30 amp for the heat pump. If there's
right.
already air conditioning, it
I
could be
see.
on a 20 amp breaker already, or it could be on a 30 amp breaker already, in which case it would be the same load on the house.
Got
Um,
it.
but I don't think any electrician is going to give that a thumbs up for safety.
Yeah, yeah. Let's see. Is there danger that the subsidy is going to be all used up? Just wondering about time urgency.
There's never a guarantee, and if the rebate is good, you should grab it. I tried to get people to buy electric cars 5 years ago before Doug Ford took over in Ontario. Oh gosh, I can't believe it's been 5 years. And everybody had every excuse not to buy an electric car. And then gas prices went way up, and they all said, "Well, where's the rebate?" Um, and there is a federal one now, but it's not as big as it used to be. I do think the $6,500 rebate for what we call the hybrid, paired with a furnace or air handler, that rebate is a little too good to be true. Usually a rebate is 20 to 30% of the cost of something to bring it in line with buying the other technology. So when people were spending $20,000 on a Mitsubishi full system heat pump, $6,500 rebate was proportional to make it about the same cost as buying a furnace and a really efficient air conditioner. But 6,500 off a 6,500 or $8,500 heat pump, I could see that. They call it coils only rebate. I could see that rebate coming down to a lower amount. So if you want to do that one, I would say get on it. And I would say get a pre-retrofit audit before March. And like Michelle said, have a plan and be able to move fast. We can install a heat pump in 2 days, and we're installing 6 of them a week. Um, we can move fast if people are ready to go. But you got to get that audit. And if there's any scare about it ending, the auditor demand is going to be the rate limiting step.
Yep, yep. Um, Somebody who's interested in the heat pump water heater inquired about limited space, and we did say you could even have it in a closet, but you would have to have a louvered door. And they say, would it work just as efficiently with that louvered door?
Yeah, yeah, I think that would be fine. It doesn't run all the time. So really, it's only when somebody showers. So if there's 2 people in the house, maybe it's running twice, 3 times a day. And so there's maybe 6 hours between the time it runs. Say it runs 20 minutes after a shower, then there's 6 hours till the next shower. There's all that time for the temperature to equalize.
Mhm. Here's something to clarify on the combo. What might it cost to run 2 mini splits up to a third floor from an already installed regular heat pump? If I understood, you said that was possible, but I'm going to check out air sealing first.
Okay. Um, it's possible if it was planned ahead of time. It's
There's only certain manufacturers and models that do that, right?
yeah, it's
Yeah.
it'll be a multi-head. Um, and it would cost more money up front. So if you've already had a central heat pump installed and didn't ask for that or weren't offered that, then it probably doesn't do that. Um, but you
But
can
this
buy.
person can check out the air sealing. So
Yeah,
I think, as you noted, a lot of people have found that second and third floors that were never got enough heat and cold after doing the duct sealing. It made a huge difference.
yeah, yeah. And the other thing with that is that I did have somebody that had asked about that recently, the multi-split, but then you're running the refrigerant line all the way up to the third floor, and this person had a deck where a little mini split unit could go, and then the refrigerant line would be shorter. And so it wouldn't be that hard for them to add a second one later. So if you have space for two outdoor units, a small heat pump is not very expensive to install.
Hmm.
Oh, and was there a question there? Oh, yeah. So for cost, so to if you were going to add a second heat pump, and I know people that have three heat pumps, um, if you were going to add a second one, that cost would be about $6,000 for two heads.
Okay.
Six to
Uh,
8,000, depending on the brand.
is a grant available for a second property to convert from gas to heat pump?
No,
Yeah, it has to be
not
primary, right?
the Enbridge rebate. Well, it depends.
Hmm.
Yes, the Enbridge rebate can apply for a second property. So this is for Ontario residents. Um, if you have Enbridge gas, it can't be propane, it has to be Enbridge. You would be eligible for up to $5,000.
For even for a second property. Um,
Mhm.
okay. Yeah, because this person does say, I have a cottage that has air system with gas heat. Um, so that's good to, that's valuable information. Um, what is the environmental impact of disposing of a furnace and air conditioner versus the benefits of installing a heat pump?
Burning gas is really, really bad. We're in so much trouble because we burn a lot of it. We were talking before at the top, Michelle and I were saying, Canada is the fourth largest producer of oil and gas in the world. We like to think we're a green country, and everybody else knows we're not. We win the colossal fossil award at environmental conferences for being big talkers about being green and climate, and never delivering and missing target after target after target. um, we have to start, and we're way behind, and is it going to work? I don't know. But I don't want to sit on my hands and do nothing. So yeah, we need to stop burning gas.
Hmm. Um, there's a huge difference between hybrid and central ducted. Who should choose central ducted and why?
If you've got an old furnace that's unreliable, a full system replacement is a good idea. Or if you've got a furnace that's been oversized and it's noisy, and when you sit in your living room or bedroom or wherever it may be, and the noise drives you crazy, or you have to turn it off to do something, you've probably got an oversized furnace, and that might be a reason to go for a full system replacement. When we do the hybrids, we do make sure that the furnace is a brand that's still in production, so that if the blower motor on it went, it is something that we could get a replacement piece for. So sometimes I saw a 43-year-old furnace today that's still going strong, which they say gets zero maintenance. They change the filter every 4 to 5 years. Um, and she thinks it's about to die. He says it'll never die. Um, but it sounds like a train when it's on. So that was a clear case of they would just be so much happier with um, a quiet air handler. And that's feedback I get a lot when I go back to a house after a heat pump's been installed, is people say, I can't believe how quiet it is. It's so nice.
Hmm. And I could see too, if you do a hybrid system and you're using the existing equipment on your gas, like the blower and the heat pump, like you said, well, when is that going to fail? And are there going to be the parts to replace it? So that could be a concern. Um, how old do you think is reasonable to do the hybrid? Like how old of a furnace would you say? Yeah, I think that blower is okay.
I think it's not entirely the age, it's the brand,
Mm,
and the care that it's had. I used to never care for, I never did the annual service, not really knowing what, if it was worth it or not. But now, having opened hundreds of furnaces doing energy audits, I have seen that, yeah, if you maintain your furnace and keep it clean, it's going to last longer. So it's, a good brand might last 25 years. But if it's cheap furnace with a cheap heat exchanger, it might rust out after 7, 10 years. So there's no rule of thumb, but uh, it's uh, it if you open it up and take a look, you can kind of have a sense how much faith you should have in it.
that makes sense. Do you use the Green Homes Grant Energy Audit report when you size your heat pumps?
Not terror. Yes. Yes. The most important thing on it is the air tightness. You get a blower door test, and there's a scaled result, um, that's relative. So a new build home today is about 3 air changes per hour. And if you're building a LEED Platinum house, or a passive house, you would shoot for less than 1 air change per hour. Old leaky homes in Toronto range from about 7 to 14 air changes per hour. And that's a big difference. If a house has an air change of 7, it's reasonably tight for an older home. If it's 14, it's pretty leaky. 14 or higher, very leaky. And you're going to need more heat. So yes, the air leakage is important, but the heating loads have can be very high, especially for older homes. So if you have a double brick home in Toronto, any energy audit will tell you that your house uses a gazillion tons of gas a year, and how could you ever afford to heat it? But we see our bills, and it's half that amount. Part of that is that we've had warmer weather, but there's also some exaggeration in there. These are cookie cutter templates, one size fits all for Canada, a house in Canada. And so most homes in Canada are wood frame homes. And so we start with a wood frame model and then pretend it's double brick. It doesn't really work out. So that's been most of my experience being in sort of central Toronto. But I've also heard energy advisors and energy experts say the opposite, that with a super efficient home, it exaggerate it's not conservative enough. Like their homes are more. I'm getting confused, Michelle. So it's exaggerated. It's exaggerated, for old leaky homes, and it underestimates for the airtight homes.
Okay.
So it depends on your house, but it's not the only factor. If I had looked, my own energy audit said I had a heating load of 82,000 BTU. And I thought, oh, I'll never be able to get a heat pump because they don't make them that big. Well, now I have a 36,000 BTU heat pump on my house, and it does fine. Last winter, the backup heat would have been needed 3 times if I'd had it on. So it's not apples to apples. When we have the backup heat, we don't have to size the unit for the heat load. The other thing on the reports that's not very accurate are the cooling loads. It says the cooling loads are tiny, but we can see on our electricity bills over the past decade that we're using more cooling than we did in the past. So it's a guideline, but it does have a disclaimer saying you should get professional advice.
Somebody says, how does 3-ton or 4-ton translate to MBH? And I'm not familiar with MBH. Are you?
Mm-mm.
Could have been a typo or else a term that we're not familiar with. Um, okay. We got 2 more questions. If I get an energy audit,
It maybe BTUs.
maybe that's what they meant. That would make more
So
sense.
so a 2-ton, 1 ton is 12,000 BTUs. 2-ton is 24,000, and a 3-ton is 36,000. Obviously, you see the pattern. 4-ton is 48,000
Yeah,
BTU.
that's a good guess. That's a good guess. I'm guessing that's what they were wondering.
So in Toronto, we basically install twos on small semi-detached, 2.5s for a big semi or a small detached, and threes for a fully detached of a good size, and four, you're at a 4,000 square foot home for fours. And of course, there's variations in there depending on insulation and age. But the 2.5 ton is the size we install the most often.
And I think that's a great illustration of why you definitely don't want somebody to just come and do a 1-for-1, like whatever size your gas furnace was, that is not the size of your heat pump. My
Yeah,
home has an 87,000 BTU
yeah,
boiler,
yeah,
and I would have a 2-ton heat pump.
yeah, yeah.
So it
But
definitely doesn't translate.
the air conditioner can be a guideline. If the air conditioner was sized correctly, um, it could be the size of heat pump you need. My house had a 3-ton air conditioner, and now I have a 3-ton heat pump. So if they got it right with the air conditioner, and you can tell if an air conditioner is too big. You want an air conditioner to run a good amount of time to dehumidify lots of your air. If it's very big, it will just run a short time. It'll cool too fast without dehumidifying. If it's too small, it won't be able to handle the hottest days. So if your air conditioner is sized correctly, that's a clue.
Great. If I get an energy audit before the March deadline, when is the time to install the heat pump to qualify for the rebate? I need time to address amperage and knob and tube in my house.
I think we're back to when is the government going to change?
Mm-hmm.
Is my
Yeah,
best guess.
yeah, yeah. That makes sense.
Um,
If they get the energy audit before the March deadline, there's a good chance that they'll have, like right now, they're giving till what is the where they're saying the it will end 2027?
uh, yeah.
Yeah, we don't know. We don't
We
know.
take it 1 year at a time. The program's been in for 3 or 4 years. I guess we're in year 3 now, right? Um, so
Yeah,
heading into year 4. So yeah, as long as the government is a good guess or a better government.
yeah. There you go.
Hmm.
Why would someone add a second heat pump? Is that because it's a very large house?
Um, I do have a client. I have a couple client, one client with 2 heat pumps. Yes, they had 2 furnaces, 2 air conditioners. Now they have 2 heat pumps. When we do ductless, for most brands, the number of cold climate heads you can have per outdoor unit is 3, and most people want about 6 heads for doing a whole house. So we'll do 3 and 3. And then I have people, there's a lot of houses being divvied up in Toronto, maybe probably elsewhere too in Canada, where it was one house and now it's 3 units per floor. we like to put a separate outdoor unit per floor in that case. So there's no communication between the various floors because maybe somebody in the basement wants heating and somebody on the second floor wants air conditioning. You can't do both at the same time if it's connected to the same outdoor unit. And even though a head can be off on a system, if another head has a call for heat, that heat, some refrigerant may pass by that indoor unit and it can spill some heat. So you could have inadvertent heating. So for separate units, whenever we can, we'll do a dedicated unit. And they get smaller. If you're doing smaller units, it's a smaller outdoor unit. And the smaller the heat pump, the more efficient it is. And with ductless, you might have one that does the back rooms of the house on one side and one that does the front rooms on the other side, keeping the refrigerant lines from being too long.
Okay.
And I have 4 heat pumps. I have a heat pump hot water heater, a heat pump for my home. I have a heat pump dryer, and it's not very environmentally friendly, I'm sorry, but we have a pool. And last year, the gas heater was replaced with a heat pump pool heater.
Nice. This could be our last question. And this is kind of relevant for changing Toronto. What would be an ideal heating and cooling system for a 1,200 square foot garden suite or laneway house?
Mm.
I mean, obviously it depends on how tight it is. But
I was at a laneway house last week, and it's going to be open, and it's already got a big duct. If you know those ducts with marks on them that you see in restaurants sometimes or at lofts, I'm told it's called a spiral duct. And the homeowner really wants to reuse that because they put the money into it, and they have a big, giant, oversized furnace for this old space when it wasn't insulated at all. And it just sort of broke my heart because it would be so much more comfortable with ductless in there. It's going to be a big open space. They could have one ductless unit on the main floor. It's going to have a small second floor bedroom. You could have a second one up there. They could put a heated floor in the bathroom. And if they had more rooms, maybe there's a bedroom on the main floor. You could have you can even do a second head on the main floor. So 2 to 3 heads, perfect zone control. People say they don't like the look of them. But I think people love the look of things that make them comfortable. And you can get really used to it if it makes you comfortable. But if you really wanted duct, I think that's what I'd do. Yeah. You can do, I have seen, if you really don't like the look on the wall, I have seen ceiling units. Somebody that ran the refrigerant lines inside their walls and did 2 on the main floor, 3 on the second floor, and 1 in the basement, and they were all ceiling units. That doesn't disperse as far as a wall unit does, but the house was modest in size, so it worked in that case. If I were doing ducted anywhere, whether it was a 4-story home or a garden suite, I would have some zone control so that if there were different floors, I could control how much was going to the floor, or if there's an east or a west side, control how much air is there. It's crazy to be with the variations of temperatures we have in Canada. To have one thermostat in one spot is very limiting.
all right. Well, with that, we're going to wrap things up. Trish, thank you so much.
Thank you. That was so much fun. As you can tell, I love talking about heat pumps.
Oh my gosh, we could nerd out on heat pumps all day. Um,
Yeah.
but what's so great about it is I think that there's a lot of people who really are interested, but it's just there are also a lot of questions, and as we saw, so it's really nice to be able to answer some of those. Our goal is to help people feel more confident to go forward with doing any clean energy retrofit, and heat pumps are really an incredible opportunity. So thank you so much for providing
Yeah.
your expertise. I think
It's
we've
a pleasure
hopefully
and a pleasure working with you too. And thank you
uh,
everybody for joining. It's so encouraging to see everybody um, uh, changing for the better.
absolutely. So I'm going to end the webinar. We have recorded this, and I will reach out to the folks who participated and enrolled, and provide information and let you know where you can find us if you have further questions. So thank you so much. Happy holidays to everybody, and best wishes for reducing your emissions and making your home really cozy.
Thanks,
Take
Michelle.
care.
Bye
Good
bye.
night.